Hi guys, welcome to another part of gravitation. In this part, I am going to teach you the next topic of gravitation. The next topic is gravitational potential energy. The amount of work done in bringing a body of mass m from infinity to a point inside the gravitation field by gravitation force is called gravitational potential energy. Here it is the gravitational field. Here these are the points at the infinity. Here these are brought to the gravitation inside the gravitation field by the gravitational force. Therefore here u is equal to potential energy. Therefore the work done by bringing mass m1 to the gravitation field inside the gravitation field is w1. The work done by bringing the mass m2 into the gravitation field is w2, and then the work done bringing the mass of body m3 into the gravitation field is w3. If you add this, we get the potential energy. Here we know that F is equal to minus du by dr. Therefore du is equal to minus f bar into dr bar is equal to minus f dr. If we integrate on both sides, and here these particles are brought from infinity to into the gravitation field. Here mass m is brought from infinity to inside the gravitation field and placed at a distance r from center of gravitation field. So we take the limits infinity to r. Here we write integral infinity to r du is equal to minus integral infinity to r f dr is equal to minus w conservative is equal to u. Here we write this value as minus w conservative, and then we get, and then here we take the, here we can write this value as u limits infinity to r is equal to, we can write this value as minus w conservative, so that is equal to minus w conservative, and then u r minus u infinity is equal to minus w conservative. U r is equal to minus w gravitation, because here we wrote gravitation because gravitation force. Here in gravitation force is also conservative force. In this case we take instead of conservative force gravitational force. Here u infinity is 0, so you can write as u r is equal to minus w gravitation. Potential energy of a body on a system is negative of work done by conservative force in bringing from infinity to a point in the gravitation field. And then gravitation potential energy of two particle system. Gravitation potential energy of two particles of mass m1, m2 separated by distance r. Here these are 2 points m1 and m2. The distance between them is r. Gravitation, here V is equal to minus gravitation potential, not potential energy. Here gravitation potential V is equal to minus gm1 by r. Work done, here W is equal to Vm2. Here W is work done in bringing m2 from infinity to inside the gravitation field. W is equal to Vm2. Therefore we know V is equal to minus gm1 by r. So we substitute here. Then we get W is equal to minus gm1 m2 by r. Here therefore we can write U is equal to minus gm1 m2 by r in case of gravitational potential energy of two particle system. And then three particle system. Here is a mass m1, and then m1 m2 and m3 are at infinity brought inside to the gravitational field. Therefore here m1 and m2 are placed at a distance r12, and m1 m3 are placed at distance r13, and m2 and m3 r23. Therefore we can write W is equal to minus g m1 m2 by r12. The distance So here we can write W is equal to minus G M1 M2 by R12 minus G M1 M3 by R13 minus G M2 M3 by R23 here. Therefore U is equal to minus if we take minus common, then we can write as G M1 M2 by R12 plus G M1 M3 by R13 plus G M2 M3 by R23. And then gravitational potential energy of 4 particle system. Here W is equal to minus G M1 M2 by R, and these is the gravitational field, and these are the particles. In this M3, M4, M2 are brought from the infinity. Here these are placed at a distance or separately, and then W is equal to minus Gm1 M2 by R minus Gm2 M3 by root 2 R minus Gm3 M4 by R minus Gm2 M4 by R minus Gm1 M4 by root 2 R. Can write in case of 4 particle system, we can write W is equal to we can write like this. Here we can see that in one particle system we have only one pair of work done, and in 2 particle system we have 2, and 3 particle system we have 3, and 4 particle system we have 6. For n particle system, this is the formula. If we substitute in case of 4 particle system, we substitute n as 4, so we can get how many pairs we can get by doing this formula. And then note, for n particle system there are n into n minus 1 by 2 pairs, and potential energy are calculated for each pair and add to potential energy of system. Gravitational potential energy of a body in Earth's gravitational field. Here, case 1. A point mass m is placed at a distance r from center of sphere. Here U is equal to minus Gm capital M small m by r into capital R by r. Hence here G is equal to Gm by r square. Here U is equal to minus mgr. U center is equal to Vg center into m is equal to, we know Vg center is equal to 3 minus 3 by 2 Gm by r into m. Here U center is equal to minus 3 by 2 into G capital M into small m by capital R. The self potential energy of a uniform sphere of mass m and radius r. Amount of work done in bringing identical massive particles to form a sphere of mass m and radius are called self potential energy of sphere. Imagine a sphere of radius x is formed. Mass of sphere of radius x is equal to m dash is equal to 4 by 3 pi x cube rho. Here rho is equal to density of sphere. Gravitational potential Vg on the surface is equal to minus Gm dash by x. Therefore Vg is equal to minus G 4 by 3 pi x cube rho by x is equal to minus G 4 by 3 pi x square by rho is equal to minus 4 by 3 G pi x square by rho. And then to increase radius of sphere from x to x plus dx, some mass dm has to be added. Here dm is equal to 4 pi x square dx. Work done to add that mass dm. We can take the work done is dw is equal to Vg surface into dm. Here dw Vg surface, we know that minus 4 by 3 into pi into G into x square rho into, we know that dm is equal to 4 pi x square dx into rho, and then we get minus 16 pi square by 3 G rho square x power 4 dx, and total work done is equal to, here is a circle. Here is a circle of radius. Here at center radius r is equal to 0. It should, here from 0 to radius r, it should make many elements and form a radius r. So we can take the limits as 0 to r. Total work done is equal to integral 0 to r dw. Therefore w is equal to integral 0 to r minus 16 pi square G rho square x power 4 by 3 into dx. Therefore w is equal to 16 pi square G rho square by 3 we take outside because they are constants into integral 0 to r x power 4 dx, and then total work done is stored in the form of self potential energy. Here total work done is stored in the form of self potential energy. Here u is equal to minus 16 pi square g rho square by 3 into x power 5 by 5 limits 0 to r, and then u is equal to minus 16 by 15 pi square g r power 5 rho square. Here rho is equal to, by the formula here, rho is equal to m by 4 by 3 pi r cube. Therefore we can write it as is equal to minus 16 by 15 pi square g r cube m square by 6. We can substitute a rho value m square by 16 by pi square into r power 6 by 9. Here this 16 and 16 get cancelled, and pi square get cancelled, and r power 6 and r power 5 get cancelled, and here is 1 r. Then we can write it as u self is equal to minus 9 by 15 g m square by r. Therefore u self is equal to minus 3 by 5 g into m square by r. Okay guys, that's all for today. I will teach you the next continuation next class. Okay guys, thank you for watching. If you like this video, please like, share, comment and subscribe to the channel, and